Today we're looking at the volume of pyramids and cones. Our goal is we can find the volume of pyramids and cones. Let's talk about pyramids and prisms to start off. Well, how do we find the volume of any prism? If we recall, we say the volume equals area of the base times the height. Remember, our capital B is going to change based on the shape of our base. Okay, we find areas for different shapes, different ways. If we find that area times by the height of the prism, we're all set. Now, the volume of a prism is 3 times the volume of a pyramid with the same base area and height. You need to trust me on this. We don't have time to do any kind of fun experiment to prove it. Just trust me. So, if that's the case, how do we find the volume of a pyramid? Well, if the volume of a prism is 3 times the height of the volume of a pyramid, we do the inverse as well. The volume of any pyramid is 1/3 the area of the base times the height of the pyramid. And again, capital B is found in ways based off of the base shape. Let's put this to work. We're going to find the volume of these following pyramids. As always, start with the formula. It's a pyramid, so we have volume equals 1/3 times the base times the height.
Sorry for the interruption.
So we've got 1/3. We have a triangle base, so to find the area of it, we take 24 times 10 times 1/2. Okay, that gives us our base shape times the height of the pyramid, which is 12. And now we just work through and simplify. So when I look at this, I see we have 1/3 over here and 12 over here. I'm going to go ahead and turn that into 4. 1/3 times 12 is 4. Nice and easy, it goes away. 24 times 10 is 240. Half of 240 is 120. So volume equals 4 times 120, which gives us 480 centimeters cubed. Okay, we're in volume, so we've got 3 dimensions we're looking at. It's cubed. Multiplication, whatever you want. Look for whatever makes it easier for you. You saw what I did. You have your flexibility. Now, we've got this pyramid. It's a square pyramid. So, formula is the same. Volume equals 1/3 area of the base times the height. Let me get this thing out of the way. So we sub in what we know. We've got 1/3 is still 1/3. Area of the base is 8 times 8. Height is 9. Well, look at this. 1/3 times 9 goes away real nicely. Gives us 3. 8 times 8 is 64. We multiply it together. Move that again. And we get 192 inches cubed. Formula, substitute, simplify, solve. Next, we have cones. Cones and cylinders have the same relationship as pyramids and prisms. So the volume of a cylinder is 3 times the volume of a cone with the same base area and height. Therefore, formula for the volume of a cone is also 1/3 times area of the base times the height. And we know that in a cylinder, circle base, the area of that base is pi r squared. So we have 1/3 pi r squared times the height. So let's try this out. Find the volume of the following cones. We'll use 3 14/100 as pi. So again, write our formula. V equals 1/3. I'm going to be specific over here. I'm going to say pi r squared times the height. So we've got 1/3 times 3 14/100 times the radius squared. Well, the radius is 2. We know that 2 squared is 4. and the height is 3. Notice how that 1/3 and 3 cancel out nicely. So we're just left with 3 and 14/100ths times 4, which gives us a volume of 12 and 56 millimeters cubed. 12 and 56/100ths millimeters cubed. Okay, try this one, guys. It's the same exact process. We've got a height of 3, radius is 7. Start with our formula. Volume equals 1/3 pi r squared height. So we've got 1/3 times pi. Radius squared. Radius is 7. We know that 7 squared is 49. And our height is 3. Again, our 1/3 and 3 cancel out nicely. So we've left with 3 and 14/100ths times 49 for a final volume of 153 and 86/100ths feet cubed. This concludes your lesson on the volume of pyramids and cones.